Hi everyone, my name is Abu Bakr, and today I'm going to be talking about how you can build your own MCP server or MCP tool in just a few minutes in Python. So why am I talking about MCP tools? Because they are extremely powerful. They give your LLM or your chatbot new abilities that it wouldn't normally have otherwise. So you can get ChatGPT or Claude or Cursor or a local LLM that's running the ability to generate videos or to edit images based on natural instructions, natural text, which I'll show in just a minute. Or you can do something completely different, like connect it to your Google Calendar so that it can, make appointments on your behalf. So the reason this is so exciting is because there are new open source machine learning models being released all the time that have very specialized capabilities. So for example, this one here, Flux Context Image Editing, you can give it an image like this one here, and you can say, hey, turn the flowers into sunflowers, and it does a pretty good job. It keeps the rest of the picture the same while turning these images into sunflowers. Now imagine being able to use this tool within your LLM. Imagine being able to use tens of tools, whatever tools you want to, from your LLM or your chatbot directly. That's what MCP allows. And so what we'll do is in this video, I'll show you how to build an MCP server, and I'll use this as an example, but what I'm describing is very general. You can build any sort of MCP server, and then I'll show how you can use it from within Cursor. But again, the process is general. You can use this within any what's known as MCP client, any chatbot. All right, with that, let's get started. All right, so let's jump to the code here. So what I'm showing you here is the code to actually build this MCP server. We're going to be importing Gradio. So Gradio is the main library that we're going to be using to build an MCP server. And the nice thing about Gradio is it also produces a nice UI. So you saw that UI. I could interact with this image slider. I could put in my own image. I could test it out. And then when I'm ready, I come back and I can actually deploy this as an MCP server. I import a few other libraries, most importantly diffusers. That's where I'm going to be getting my machine learning model from. This Black Forest Labs Flux One context dev model. I'll be loading this into my GPU, and the platform that I'm using to run this is Hugging Face Spaces. But again, you could be running this locally or on your own server anywhere. The code will be exactly the same. I define a few parameters, such as how many steps I want to run for the seed, for reproducibility. And then now I get to the main point here. So first I have to define a function. So in this case, the function is called infer. And it just takes in a couple of parameters like my input image, my prompt, just the string, describing what I want to change. And then we'll come back to this kind of this other stuff here. But this process is quite general, right? So what I'm going to be describing here is a function that, edits an image using this model, but anything that you can envision as a Python function can then be wrapped as an MCP server. All you have to do is define the function, write the doc string. This is important because it not only for humans, but it also gives the LLM context for when to call your tool. And then, all this tool does it takes the input image, and then it pipes it through my model with the prompt that I've given it. And then finally, I just return the original image as well as the new model, the new created image. And I'll come back to why we return both of the images. But okay, so just pretty simple function. Again, this could be anything, any functionality you want to give your LLM, whether it's counting the number of letters in a word to creating videos. If you can encapsulate it in a Python function, you can make it accessible to your LLM. Finally, then we come to the Gradio part of the code. So we're going to create a Gradio's interface, which is kind of the main high-level class in Gradio. You give it the function that you want, which in this case is just the infer function. And then here you give it what input and output components correspond to this function. So for every parameter, every one of these core parameters that we have here, input, image, and prompt, I have a component. So for the input image, I have an image input component. Makes sense. For the prompt, I have a text box input component. Makes sense. And these are extra parameters. You don't need any of this. This is just for the UI actually. But I'll go ahead and do that. And then finally, I have for the output, I do the same thing for the output. For my output, I want an image slider so I can get that nice UI that we saw earlier. And that's actually why we return both the original image and the new image, so that we can get that nice UI there. And then I give it some examples which are cached so I can easily run this. And then finally, I launch my application by setting MCP server equals true in launch. This is important. This is what makes it an MCP server, and I'll show you the impact of this change. But if you don't run this, then you just get the UI piece. But if you add this parameter, MCP server equals true, now your LLM can actually use this tool, which is great. Now, if we go back to our UI here, our application, we saw this earlier. It's the same UI. Great. You'll see this MCP tag, which Hugging Face Spaces automatically adds to let you know that this space, this application, can be used as an MCP server. Now, if you go to the bottom here, you'll notice that it says here you can interact with this application via MCP. Great, that's what I want to do. So what I can do is I can just scroll down here. I can copy this. Now, this needs to be added to my MCP configuration to whatever LLM that I want to use. It's that simple. So I just copy it. I go back, and now I have Cursor open. So with Cursor, I can edit the MCP tools that I want Cursor to use. In this case, I'm just going to edit this. So yours might be blank if you don't have any tools, and just paste it here. And now I have this. Now in Cursor, I can go back and I can enable both of these tools. There's two tools that are added actually. So one of them is the tool that actually edits the images. The other tool is one that lets you upload files to Gradio. Now, you don't have to enable this one, but if you want to use files locally from your computer, then you have to enable this. If the MCP doesn't require files, then you don't have to worry about it. By the way, actually, I should mention, so if you have this one, for security reasons, you have to specify an upload directory. So in this case, I'm going to go ahead and just say this repo, this repo over here will be it's going to be the directory that is authorized to upload files to Gradio. Just for security reasons, you don't want to make all your entire file system accessible to a remote, kind of MCP server. So you have to explicitly provide it. And then here, again, you have the core MCP tool. Okay, so we have that here. Everything looks good. Now I can actually start using it. So what I'm going to do is I have this picture here, a picture of Einstein. So what I'm going to tell it is upload Einstein and then add glasses to it. Now, the reason I'm telling it to upload is because I wanted to use the upload tool. Okay, because basically, if you don't upload it, all of Gradio's MCP tools, they require files as URLs. So public URLs, they need to be accessible. So what the upload file tool does is it takes a local file, uploads it to Gradio, gets a public URL for it, and then passes it to the actual tool that you care about. So in this case, I'm just telling it explicitly. It can probably figure it out if you don't say this, but I'm just explicitly saying it. Upload Einstein.jpg and then add glasses to it. Well, so it does that. It uploads it, then it calls the Flux context tool. Great, and then here are the results. The original image, the image with glasses. Let's take a look at how it did. Hey, not bad. You can see here, the original image is still there, and now Einstein has glasses. And that's really it. That's how you build your own MCP server. That's how you use it. Again, take the meat of that function, that Python function, take it out and replace it with anything else, and the process will look exactly the same. And yeah, good luck. I hope you build lots of amazing MCP servers. You can keep them local, or you can host them on Hugging Face Spaces for free. And we look forward to your feedback.